Hey guys, Mr. Sonnenberg here. Today we're going to be talking about metals, nonmetals, and metalloids. So the first thing when we talk about metals, we need to look at the periodic table of elements. So this is a periodic table that arranges them based on atomic number, also by atomic mass, and the table moves from left to right on what we call periods, and then it's going to just go left to right back through the period, okay, all the way across in that direction. But we need to identify where the metals are on this table. So if I take a look here at the table, the metals are actually going to be on the left side. Okay, so they're going to run across the table all the way to what we call the staircase. Okay, so now the staircase is going to be here, okay, and it's going to move down. Everything on this side is going to be metals. Everything on the other side are non-metals, okay? So these are things like calcium, sodium, lithium, zinc, gold, okay, iron. Those are metals, all right? So you should be able to look at a periodic table and identify which are metals and which are non-metals, okay? So let's talk about some properties of these metals. So like I said, gold and silver, copper, sodium, lithium, those are metals. Okay, so what's going to happen is they're going to appear shiny in color. They're going to be very hard, okay, or just hard. Some of them are a little softer metals, but mainly they're hard. They're going to be malleable, which means we can shape them, or we can pound them into sheets, whatever we want, but we can shape them. They're going to be ductile. And so by ductile, I mean we can actually stretch them almost like a wire. Okay, they're going to be good conductors of heat and electricity, and at room temperature they're going to be solid. Now their density is also going to be high, which means how many particles are packed in to that solidified form. It's going to be very dense. Okay, so what I have right now is I have a video clip that I'm going to show you. Okay, that looks at a way we can identify metals. And what you can do is you can actually do a flame test, and you can identify what metals are in that substance based on the color of the flame. So I just want you to watch it. It's about 50 seconds or 45 seconds long. Okay, I'll see you. I'll be right back on the screencast after you watch it.
Very dramatic version of the flame test demonstration here. First we have alcohol burning blue, then we have some barium chloride with the barium ions burning a dirty yellow color. Then we have boron being green, strontium giving us the crimson red color. Next is calcium giving us the orange. Not showing up very well here in the next one, but the red tints inside of that orange there's some impurities there. That is lithium. Next we have sodium giving us a characteristic yellow flame. Then we have copper with its green color. And finally potassium with the purple or lilac shade.
Okay guys, so hopefully you understand that if we burn different metals we can get different colors. So if you think about metal, or when you're around a campfire and you throw things in and all of a sudden the flames are different colors, that's because it has metals in it and it actually changes the colors. Or fireworks, you have all the different colors, that comes from metals. Okay, so those elements, those metals that you find on the periodic table, the different colors come from different metals. So now you understand, oh wow, look at those fireworks. Well, that's because of the metals in them, and when you burn them you can see flame tests. Okay, so let's talk about nonmetals right now. So nonmetals are going to be found on the other side of the periodic table. So we identified which ones were on the right. Those are metals. Nonmetals are going to, or on the left, sorry. Nonmetals are going to be on the right. So this portion right here, these yellow on the periodic table, that's going to be kind of a section of this right here. So the green is going to outline. So we have helium, we have neon, we have fluorine, oxygen, nitrogen, carbon, phosphorus, sulfur, chlorine. Those are non-metals, okay? So you can find those on the right side of the periodic table, but let's take a look at some of the properties of non-metals. So they're going to be dull in color. They're going to be very brittle, so they break easily. Malleable, well, they're not malleable. Okay, you can't shape them, they'll just break. They're not ductile. You try to stretch it, it's just going to break because it's brittle. They're very bad conductors of electricity and heat, okay? And they can be solid, liquid, or gas at their state. Okay, so they can change, and there's a variety of states that you'll find these nonmetals in. And then also their density is quite low, so they don't have a lot of particles packed closely together, and that's what actually kind of assists in them being very brittle. So then the last thing we need to talk about is what we call nonmetals, and basically metalloids. Metalloids are going to be a combination of metals and nonmetals. So they'll have some properties of the metals, some of the nonmetals. They'll act like nonmetals, but they'll react with metals. They act like metals, or they react with nonmetals. Okay, and they can be semiconductors. So sometimes they conduct, sometimes they don't. Okay, so if we take a look at the periodic table here, what you're going to see is this purple right here, right by the staircase. Those are going to be your metalloids, right between the nonmetals and the metals. So on that first row, so if you take a look at those and identify them with your periodic table, you'll know what the metalloids are. So what I'm going to finish with is I have a cool video clip that's about 1 minute and 5 seconds long that's going to just show you how some of these alkali metals in the first group of the periodic table, so lithium, sodium, potassium, how they're going to react with water. And it's pretty cool to see what actually happens. So I'll end here, watch that video, and I'll see you on the next screencast. Bye.